Hey everybody, this is Jim Neeb. I'm finally doing the last final review video of the RapidChange ATC. I don't if you've watched any of my previous ones. I was kind of walking my way through testing some of my concerns with this. As I mentioned on my very first video, I was given this unit from Rapid ATC to try out. I didn't buy it with my own money, but I thought it would be a fun project to check it out. It's kind of a new idea. There's been a few people that have shown a video of something similar, but this is the first time I think anybody's ever actually productized this. And on the surface it looked great because it's low cost, it's small, it's very flexible. You can buy it in a lot of different options, but it uses the spindle's motor to actually spin the nut on and tighten it and to take it off. And so there's some concerns that come with that. So I've walked through this in a series of videos, kind of dispelling all my concerns one at a time. And this video, there was two left. One was, as you may recall in the last video, I showed that the torque values of the motor spinning the nut on were in the order of 12 to 20 pounds. And compared to what I normally have been doing for the last 5 years of hand tightening, it was just a little bit under that. I could always, after the ATC tighten the nut, I could always tighten it just a little bit more, but not very much. So I did one final test here to try and kind of run a torture test on some really hard wood with the bit that I've had problems with coming loose before. And honestly, I haven't really had much trouble with bits coming loose, but the one bit that I have that has done that, I did a test with. The other concern that I haven't gotten to yet until now was when these collets are loose, the bit can slide out and fall down in here. So normally with a normal ATC, the collet and nut is tightened into a tool holder. So, or when you do it manually, when you mount manually, you put it in there and you tighten it right away. You don't have the collet sitting there with the bit is hanging in by the pressure of the collet only very often. And in this case, it's placing it in there and there's a lot of vibration and everything. So if you have a loose collet, the bits can fall out. So I found that a certain percentage of collets just come loose. And so I needed to come up with an alternate, either a better supplier that can always make collets that are tight or something else. So I have two solutions for that coming up. And then I'm going to show a final fully automated video clip of running the making of this sign that has 5 or 6 tool changes in it. And then I'm going to do a kind of a high-level summary of the whole thing and give my impressions of the product. So let's get into the first couple items here first. So what I'm doing here is kind of a test to see how, basically to see if the bit holds. So on a really kind of a torture test here. So I've loaded the bit with an ATC, with the ATC manually, using just the macros first. And then I put a tape on here right at the bottom of the collet so I can see if it's moved. And then what I'm doing is cutting a 0.8 inch deep pocket in some really old, gnarly, dried mesquite, which is really hard wood. This bit is actually a bit that I almost threw away. It's very dull, and it actually did slip out of a collet on me previously that was damaged. The collet was damaged, not the bit. So I know this bit has experienced slipping out of collets because of its dullness and stuff. So this is, like I said, I've done a bunch of torque measurements. With the 1/2 inch bits, I get 16 to 20 pounds of torque with the ATC loading it. And this, I've never had a problem with the small bit. So the only bits I've ever had come out are very long 1/2 inch bits when I'm pushing it hard like this. So this is my best attempt to see if a bit will slip being loaded by the ATC. So I'm going to cut a few pockets, then I'm going to reload it with the ATC and cut a few more. So I'll go through this like 3 rounds, and each time I'm going to put the tape up tight to the collet or the collet nut, and so I can see if it's moved or not during the process of cutting this. Alright, so I cut 2 pockets at 50 inches per minute, half or 0.4 inches depth of cut, so the pockets are two levels down. Then I switched up to 100 inches per minute, 3 pockets, and the last run, or the last ATC load, I did 5 pockets at 100 inches per minute. You could hear how hard it was basically barking all the way through, because like I said, this bit is very dull. It was very hot coming out of there. Normally they aren't. So I think this is a pretty good stress test. This bit is sticking out at least 2 3/4 of an inch from the collet. It didn't move at all each time, and really I didn't expect it to, because after it was done cutting, I put the wrenches on it and squeezed just to see like how much would it move if I put the normal amount of hand tightening that I normally do, and it barely budged. I mean, twice it just had like one little slight movement. The other time it didn't move at all. So it's really getting, it seems to get the 1/2 inch or the larger shanks tighter than it does the smaller shanks. I don't know what the mechanics of that are or not. Maybe it's just due to the smoothness or something of a couple of these collets I have. I don't have a huge selection. I only got 2 1/2-inch collets, and one of them doesn't hold bits tight enough right now to use with this. So maybe it's just a coincidence, but the smaller, the 1/8 inch or the 1/4 inch shank ones do seem to, and especially the 1/8 inch ones seem to be, down more like 12 to 15 pounds. But on the other hand, that seems to be plenty to hold them in place anyway. So because they're so short, put as much force on them. So pretty happy with this. I don't really have any worries now about this being enough torque to hold bits. Between all the torque measurements I've done to see how consistent it is, as well as this torture test just to see if the bit moves at all, I'm convinced that this is just as good as the normal hand tightening that I've been doing for the last 5 years. Okay, so one of the cool things about having a YouTube channel is you can get feedback from people or ideas, and this project is no exception. So I had mentioned that some of these slipperier collets that can't hold a bit like this one, it just wants to fall out. One of my viewers named Randy said, can you put something inside of there to hold the bit up, like a little plug or something? And so I thought about it and was like, hey, that's a good idea. So I got some of this, it's called backer rod. Basically, it's just a long coil of tubing. This happens to be, I think it's 1/2 inch or 5/8. Yeah, it's 5/8. Got this off of Amazon, super cheap. And I also ordered some 1 1/4 or 1 inch, I guess, to go in the larger pockets that I have. But basically what I did is I measured the distance from where the collet sits on down to the bottom. And then when I have a bit that's inserted, get my finger out of the way there. When I have a bit that's inserted a certain distance from there, So I just take that total depth that I measured in there, subtract the tip of the bit to the nut there, and get a length, and that length is how long I cut this little piece of foam. It's just cheap disposable foam, and I throw it down in that hole, and then I can put the bit in. Like I said, this one won't even hold itself in with gravity, but I can put that in there, and this bit would fall out every single time I tried to use it. Just wouldn't stay put. I just loaded this 6 times, so you can kind of feel it just springs back a little bit there. So I cut the foam at the right height so it just keeps that bit from falling out when it's loose. And I loaded this 6 times and looked at the tool offset value that I got when it probed, and it stayed within about 100 thousandths across the 6 loads, and never fell down. So, and it didn't seem to chew up and destroy that foam either, which I was a little bit worried about. This is a really sharp bit. There, it just fell out. It's a square end mill, and it didn't tear that foam up. So that seems to be a one way. If you can't get the collets that are snug enough to hold them by themselves, this works really well. I mean, you do have to cut it off to the right length and everything, but I think most people would have a pretty standard loading of their magazine probably, so you wouldn't have to do it that often. But it's really easy to measure this. In fact, you could make yourself a little gauge right on the table here with that total depth, and then lay your bit on it and collet nut, and then like if you did something with like a line and the nut, and you had your other line for the depth, you could simply put this tubing up there and just say, okay, cut it off there. So it'd be really simple to make a little marking gauge right next to this, so you didn't actually have to measure each time. You just throw it up there and chop it off with a X-Acto knife or a scissors or something. So that works very well. Thank you, Randy. That was a good suggestion. Just like the suggestion to put some foam in the bottom of the magazine to hold the bits from falling out of these loose collets like this one. It won't stay in there. The foam idea was great. I got that from one viewer. Another viewer said, hey, why don't you try some other collet companies? This company called Meritool is based in Illinois, so it's American made. I never heard of them before, but I looked them up. They don't sell through any other resellers or anything. You just buy directly from their website. So I bought a few of their collets. They're a really good price. They're about 20 bucks for the standard ER20s, when I was paying about, I don't know, 27, 28 bucks for Technics collets that I got off of Amazon. And I don't have any complaints about the Technics. They were nice collets, had very, less than a half a thousandth to run out, that I, basically as low as I can measure. And they were good quality, but they also, some percentage of them were loose and didn't hold the bits. And so I was still looking for somebody who might be able to produce some tighter ones. So I bought some of these Meritool ones, and they're really nice. In fact, I think they're machined better than the more expensive Techniques. I got them in like 2 days. You buy them directly from their website. So, like I said, 20 bucks for these. So I bought 3 of them. I bought a 1/4 inch, a 3/8, and a 1/2 inch bit, or a collet. And the 3/8 and 1/2 inch were very tight. And I believe this is the 1/4 inch one. And you can see it's just extremely loose. And so I sent an email to them, and the owner of the company responded, Frank Mary, and said, that's kind of a typical thing. When they machine these, they're all made, the outside, the taper, and the hole inside are precisely cut, but then they have to cut the slots in them. And he said sometimes the billet that they're cut from, has some stress or something in them, and so when you cut the slots, some percentage of them open up a little bit. And that's kind of what I see, is like, 60% of them I buy from various suppliers work fine, and 30 or 40% of them are loose like this, and there's nothing you can really do about it. But he suggested they make collets like these called rubber sealing coolant collets. And there's two differences on these that are significant. One is they have half as many grooves cut in, or slots cut in them. You can see this, and basically has 8 cut in here from the top, and then there's 8 cut from the back side. This has half as many, so there's 4 from the top and 4 from the bottom. So when I look at that, to me it's like half of the opportunity to open up as the other ones. And then the other thing is, since these basically have these little rubber plugs, so there's an extra hole drilled in the front facing slot, because these are made to use with a hollow end mill that they can provide coolant through, and these plugs seal the passage so the coolant can't squirt out the sides. It doesn't lose pressure through the collet, and it comes out the center of the end mill is hollow on those, and all the coolant's supposed to go out there. And what he suggested was, basically you can put the bit in. Now this one's very tight to start with, so I don't have to do anything, but you can put the bit in, and then you can push these little rubber plugs in with like an end mill, or this is a punch that's small enough to fit in there. You don't want to do this with no bit in there, or you just popped it. It's just basically a little rubber plug. But you can push those in against the side, and if that doesn't work, you can very carefully push it in without the... There, I just made it protrude a little bit, so you can kind of play around to get that in the right position, so it just has a little bit of friction on there. And so these kind of have a built-in retention mechanism, the way I look at it. They are a little more expensive because they have to do the extra machining step and put that plug in there. These are about $27, whereas these are around $20 from Meritool. But to be able to guarantee that every single one of these will be able to hold a bit up in the magazine, to me that's worth it. It's better than buying 100, every time I buy 2 I have to buy 3 just to make sure that they come in tight. And like I said, I think these have a better chance of being tight even without the plugs, just because there's less slots cut in them. I tried these with, compared to torque that I get from loading the 8-segment ones versus the 4-segment ones. I didn't see any difference in that. So thank you for suggesting. I think it was King Zeus. I don't know his name, but his handle was King Zeus on YouTube. So thank you for the suggestion. I think that's a very workable solution there. So I think there's 2. My biggest concern has up to the end here, after getting through all the reliability and the other issues, was how do I make sure the bits stay in the collet when they're in the magazine. So I think there's 2 good solutions. Putting the foam tubes or foam rods down there for the right length works great. It's maybe not as convenient because you have to measure and cut some off, but that works. But these collets are also a very good option too. So I think that, to me, that problem is solved. There's multiple ways to skin that cat. So again, this company is Maritool. You can just look them up on the internet. Meritool, I think it's meritool.com, and you can order them right off the web. They ship quickly because they have them all in stock. They have everything from the smallest you can get to the very largest you can get in every collet size, both metric and imperial. So then they have all kinds of tool holders and other CNC machining stuff. So it all looks like it's very nice stuff. But so I bought 5 of these in total so far, and like I said, the quality I think is great. The runout I measured, again, under half a thousandths. I don't really have a ability to measure much better than that because my dowel pin that I use isn't any better than that. So they spec, I think, 3 10,000ths, maybe 0.3 10,000ths, I can't remember, but significantly better than I need for a CNC router for sure. So and at $20 and $27 for the two styles, I think it's a very good deal. So anyway, I just want to throw a shout out for that, and thank you to King Zeus. Well, let's try and do a fully automated project now, just to kind of show the tool changes in action, and the whole process that we've kind of worked through on the Avid machine with Mach 4. So this project has 6 tool paths in it, and I intentionally made it very inefficient because it's going to use the 45-degree bit 3 times, and instead of doing all the tool paths in order, I actually spread it out on purpose just to show more tool changes. So anybody that tells me this is not an efficient way to do it, I know I did that on purpose. So we got 3 V bits and 1 1/8 inch end mill in this thing. The 1/8 inch end mill is a clearing path for one of the V carves. So what I wanted to show first was that the only thing you really have to do in Vectric is number your tools. So for example, first thing I do is I write down all of my bits that I'm going to use, and then which pocket I'm going to put them in. And I didn't actually put them in order of use on this intentionally. 2 reasons. One is I wanted to show that you can put them in here in any order you want, as long as you name them properly or identify them by pocket number, or tool number I should say, in the G code itself. And the second reason is I have to, because this 45-degree bit won't fit in one of my first 3 pockets because it's bigger than if you saw in my other videos, the original design of this for the ER20 collet only allowed about a 5/8 inch bit, and this 45-degree bit I have is bigger. But with the updated pocket size that I have in the upper 3, that one fits easily. So I have to put that one in one of my top 3 pockets. So if we go back to V-carve here, I'll just show one of these. I mean, literally all you have to do is go pick one of these tool paths, go up, and then I don't change it when I select it. I don't want to change. I leave all of my tool database such that they're all bit 1, because that's the way I would run them normally for manual tool changes. So I want to leave the default to 1, but once it's selected in the tool path, then I simply go into edit, go down here, and you see I've got bit 4 because this is my 45-degree bit, and that's the pocket that it's in. So when I select it and calculate that, it'll save it, and you don't have to do anything special, just that when you go to save your tool paths, you're going to select all visible tool paths in one file, and as long as you use like the default Avid post processor, it's going to put those tool change in the right places automatically. So you really don't have to do anything special in V-carve. I would assume Fusion 360 is the same. I'm not really a Fusion 360 user, but all you have to do is make sure each tool path identifies the proper tool number, and it's going to generate your whole G-code file all in one piece just fine. So as I mentioned, I have 3 V bits and 1 end mill. So I want to show the whole process using the Avid touch plate, and so obviously V bits you can't use to set X and Y. So what I'm going to do is load up tool number 3, which is my 125 thousandths end mill. So that one will allow me to set my X, Y, and Z first, even though this isn't the first tool I'm going to use, but it's easy to select it. Now I'm going to use the MDI window here, so this T3M6 command, that's a change to tool 3, and the M6 tells it to run the M6 manual macro, so that's what does the switch. Now someday I'm going to write a proper screen for this. I don't have it yet, so there's all the macros are there today, supplied by RapidChange, and they work great. But there's no screen for it, and then there's a wizard. I can show there's a nice setup wizard. This is very nice. It's all of your parameters for everything that needs to be set up. You know, do you want to use an external touch plate or an internal touch plate? What's the coordinates of all your pockets? What orientation do you have? What speed? Here's my load RPM and my unload RPM. So all of this stuff is in a nice wizard. You can save. You can save and exit. It's nice. You can update. You don't have to reload Mach 4 or anything. So that's all there. But they do not have a Mach 4 screen. But since the macros are all there, there isn't really much code to write a screen. So that's going to be an easy thing to do. But that's one of my next tasks. So let's run this MDI, and we're going to see. We're going to swap out to the tool that we're going to set our X, Y, and Z with the Avid touch plate first. So I'm going to execute that. And then we'll see. It's going to take basically it has the last tool that I used before, and it's putting it away. Now it's going to load the 1/8" end mill. And it's going to do the tool offset for this. Now previously, I think in my second video on this, I mentioned that RapidChange put in a master mode option to use so that the Avid touch plate routine could be used, because Avid's touch plate routine disables the tool offsets compensation when it runs. So there's no way to use it with raw tool lengths, but that turned out to be a little bit. It was just more support than was really necessary. So what they did instead was they took that out and they just simply added a Z-Touch routine that keeps all the settings in Mach 4 correct, so that you can do a Z-Touch off with the tool setting of the current tool. So I'm going to show you how you can use the Avid touch plate routine first to get your X and Y, and you do Z, but then you can come back and run the macro to override it with the proper Z. So now we've got the right tool. I'm going to put the camera on the stand and then go through the rest of the setup process. Okay, now I've just set X, Y, and Z with just the stock Avid touch plate routine. However, the Z is wrong because it's not relative to the position that is picked up in the tool setter. It's just with 0 offset, so it's off by about 11 inches. So I could just run the Z in this corner again, but when you're doing a bigger project like this, it's better to get your Z set sort of in the middle, because that gives you a better average working height. I mean, nothing's perfectly level, so you get a little better average that way. So now I'm going to run the M132 macro in the MDI window. And this is just doing, it's similar to the, oops, I was a little bit was a little bit too far away, so it hit its maximum distance. That's also a settable parameter. So it did a double tap on that, just like it does for the tool setter position. So it's kind of nice. It comes in rapidly, touches, backs off, and then does a soft touch. So now we've got everything set, and we can run the file. Okay, so I've touched off tool 3. This is not one that's going to start with, but it knows what tool is loaded yet, because as long as Mach 4 is running and you switch tools, it keeps track of that all the time. And we've set the X, Y, and Z with the Avid tool changer. Then we've run the RapidChange macro number 132, which sets the Z height with the tool set offsets in place. So now we can run the file, and I'll run the first one at normal speed, and then I'll run time lapse just to speed things up. It's going to be kind of messy because I don't have my dust collector on, and I still don't. This dust boot from Avid is awesome, but it's not compatible with the tool changer, so I have to leave the dust boot part of it off. So it'll be a little bit messy, but that's okay. It'll also show that a little bit of dust is okay, because the lid over the ATC kind of keeps the collets and nuts clean and everything. So here we go. For the touch off, it starts pretty high, and the reason for that is I have some 3-inch, half-inch diameter end mills, and so they're very long, so I have to accommodate the worst case length bit so that it comes in above. So some of these short bits start a little high up. That was tool path 1. All right, that turned out pretty good. So I've got probably 200 cycles now. The last 200 cycles have been air-free with this. So a few, I'll put some tips at the end for getting this thing set up to be reliable, but it's really a matter of getting everything, mounted correctly and getting the right coordinates entered for the IR sensor as well as the pockets, and then this thing just plain works. So gotta put a little paint on this thing and it'll all be done. Okay, I think I want to just give a high-level summary of the product again and give my final recommendation. So this unit comes in I think 4 magazine positions to 8. I have the 6 socket or 6 pocket version here. You can get the plain ones that don't have the automated lid or the IR sensor. They just basically have the pocket with the gripping mechanism. I really like the the lid though, it keeps the dust and stuff off. It's a little dirty now because I actually had the lid off before when I was blowing around with the air compressor. And the IR sensor that's built in is phenomenal. It's a simple thing, but it really works well. I did add this tube to kind of shroud it from the light that came in from my garage door. I just got an email back from RapidChange last night, and they've actually started to design a shroud similar to this that will come with the product in the future. So that problem will be solved. Several of us that have gotten these early had the same issue with, like, it works great inside in your garage or your shop, but as soon as you open a big door, the infrared light from the external, from the sun, can flood it and cause the sensor to be flooded with infrared and not trip. So that solves the problem 100%. So I never had an IR failure once I put that on there. So it always detects if the nut's not on there at all. If it fails to pick it up, it always detected if the nut cross-threaded and didn't thread on properly, and it always detected if the nut didn't come off when we were spinning it off to go to get a new one. So that was 100% solid. And just like with the other aspects of setup, there are two heights to get that beam there. One is to detect the collet being there, and then the other height is to detect whether the nut is spun on. So you need to spend the time. They have videos on their website, RapidChange does, on how to set those, and they also have documentation with drawings of how to set that. It's important to spend a little time and get that done right, but like I said, once that's done properly, it just works. The second tip I have is you need to spend some time, two things. It needs to be mounted square to your axis. So the software is configurable. You can mount it down the X or down the Y and anywhere on your table that you want. But you need to have it very square, because one of the parameters that you're going to set is where is the number one pocket. And number one can be over here or over here. It's also very configurable. But once it goes from there, the rest is done by spacing, and it needs to be down that axis. So I had some problems with cross-threading and reliability down in these last two pockets because I didn't have this. I think I was about maybe 15 thousandths off from straight down the axis. So once I adjusted that, I had no problems after that whatsoever. So again, get the alignment done right up front and you won't have any problems. You can mount it high like this. Once I got it aligned accurately, I didn't really have any problems. The reason I did this was because I wanted to be able to put long bits down here, and I didn't want to have to drill a hole or cut a big square out of my spoil board. But everybody's situation is different. If you're willing to make it permanent and cut a hole in your spoil board, then I would actually recommend not mounting it up on blocks. Just cut a nice square or rectangle that's perfectly tight to the sides of this, and that way it can't come out of alignment, and it'll be guaranteed to be straight, straight with your axes. So that's that tip. As you saw previously in this video, there's a couple of options for not dropping bits. The coolant collets work well in my case, because I've got the spoil board underneath this block, putting a foam, basically a foam spacer or tube in there to hold the bit up so it can't fall out. It worked great. I ran quite a few changes on that, and it didn't chew up the foam or anything, because it's basically lifting it off of there as soon as it tightens up anyway. So it's not like it sits there and spins and tears up the foam. So that's it. I mean, I'm 100% sold on this. I have all the concerns I had in the beginning: not enough torque, cross-threading. You saw a couple of videos ago, I tested a bunch of cross-threading. I probably had a dozen cross-threads on this. It never put a nick on my threads on the spindle or the collet. I did hear of one person that did report they had a problem with it, but they were running at 6,000 RPM when they did that, and I was accidentally doing that too in the beginning, and I actually damaged a couple of these pockets. So that's the other thing is your spindle. You have to have a spindle. This won't work with the router because it needs to go forward and reverse. most of your CNCs, for sure the Avids, are not configured to go in reverse. So you have to add a relay and do a little software reconfiguration, but it's not that hard. And the other thing you have to do is make sure you can run down to about 1,000 RPM or so. The Avids come configured with I think it's a 30% of max RPM is the minimum. It's the floor it's programmed in the VFD, so you can't go any slower than that. So you have to reprogram the VFD, which also isn't very hard. And if you go to my Google Drive, I've got directions for how to do that on the Avid machines. I've got the link for that down in the description section. So you have to get your spindle configured. Two things I have to work on is I'm going to make a screen set to do, I would say, I guess, manual automatic changes where I can push a button and it'll go pick a particular tool and swap it out and do the touch plate. I'm going to use it that way. I don't really have a need to do a fully automated run, but I really like the idea of being able to store my most popular bits in here and just pick them and go. And that way I don't have to take my touch plate out. If I have a couple different ones, I can select it really quick and load it up and go. So it's a lot more convenient. And then once in a while I'll do a job that has 3 or 4 bits in it, and I can do an automated one if I want to. But the last thing I want to do is solve the dust collector problem. Most ATCs are challenging with a dust boot, and this one's no exception. This one would probably actually work without this is the Avid dust boot if you just took this off, but you know that kind of defeats and you didn't have the lidded version. With the lidded version, you really can't even have this on. I have to take this cover off to be able to get enough reach in there and not hit these side pieces. So I'm going to work on a different design. I'm thinking I might even be able to modify the cover and the shoe to make this work. So those are the two things that I'm going to do there. But you know, that's not unique to this ATC either. So the other thing I wanted to mention is they're always making, this is a pretty new product. I think they launched it maybe in November or December last year. They're working on new improvements. Like I said, they've added the IR cover. They're working on a sidewinder, they call it. It's basically one where it's kind of a fork, more like a traditional ATC where it kind of comes in from the side, but it still uses the spindle to load the nut, tighten it and loosen it. The purpose for that is to use like really big bits. So you could use your slab slayer or a couple of inch diameter bit on that. So they're trying to enhance all the limitations, or I should say, trying to cover all the bases for the different things that people would want to do. These current ones, just the stock one will handle a 30 millimeter hole, so that covers 95% of my bits. Some people that use a lot of really big bits may have problems with it, but that's again what they're adding the sidewinder for. So it's also designed in a way that the parts that would wear out, like the lid over time, might get cracked, or you might drop something on it or damage it. It's pretty tough, but over time it'll probably wear out in a couple of years, as well as the pockets with the little ball bearings are very easy to change. The piece itself that would wear out is very small, and so I know RapidChange is working on getting a parts list and ordering the ordering capability on their website for ordering those. I would call them consumables. So in the end, I found an answer for every one of my concerns. I'm really happy with it. So this is the last video. I might do a video later if I get my screen working, and if I get a dust collector or dust boot solution going, I'll definitely do a video on that. But this is it for this. I'm 100% convinced this is a very solid product. RapidChange actually uses multiples of these magazines on their CNCs to make these magazines, so they've got a lot of reps in over the last year. So besides, I probably have 500 cycles on this, and the first 300 were me trying to tune this in, do reliability testing and everything. Once I figured out all of my settings and get the alignment, my last 200 cycles have been totally error-free. I haven't had any IR failures. I haven't had any cross threads. It's just worked. So very good product. I think it's very reasonably priced if you compare it to, you know, the other ATCs where you need to get a new spindle with that has the pneumatic tool holder and all the tool holders and the racks and everything. So very good option for people who have smaller CNCs or don't have as much budget or don't have the need for the traditional ATC. So I think in summary, it's a great product at a good price, I think. So if you have any questions, please put them down in the comments or any feedback. I always answer everything. Thank you.